So this is going to be the 1B portion of the first video. You're going to hear about me talking about in the future. What we're going to do is we're going to kind of leave off where we got cut off in the last video. I do apologize here because I'm doing this at night and the shade is kind of covering in a little bit here. But what I go back to is the idea that everything we're going to deal with in chemistry, there's always a system and the surroundings. So like the reaction is the system, the outside of the reaction is the surroundings. And there's two main types of reactions, exothermic and endothermic. And I think we both know that with exothermic, we talked about before, that's when heat is being released, and endothermic is when heat is being absorbed. Now, there are two graphs, and we're big fans of graphs on the AP exam. And this is one where it shows the energy going up here, and this is time as a reaction goes on. And right here, you have your reactants. And actually, I'm going to do that a little bit higher up because I want to make sure it's really clear. Here you have your reactants, and down here you have your products. So these are your products. Now, when the reaction starts going, in order for it to get going truly, it has to overcome this activation energy here. So from here to right here, we call that the energy of activation, or EA for short. And that can sometimes be lowered if you have a catalyst or something that causes the reaction to work a little bit better. But if you notice here, the energy of the reactants versus the energy of the products, this gap right here, that is the change in energy that we're interested in. That's actually the change in enthalpy for the reaction. And that's the products minus the reactants. And if you notice here, our products have less energy than our reactants do. So we're going to have a negative change in enthalpy. And that's really wonderful. Conversely, if we have, I'm going to do a different pen just for subtle differences here. If we have an endothermic reaction, we're going to have our reactants at a lower mark at the beginning. We have to overcome a much higher energy of activation, and you end up with your products at a higher amount of energy. So if we take a look at the change in enthalpy here, the change in H for the reaction, it's going to be a positive change in enthalpy. And no reaction likes to have a positive change in enthalpy. So endothermic reactions are very much less likely to work than exothermic reactions are. And it is important that we understand that the signage here, and this diagram right here shows that if the energy is leaving, we say that is a exothermic reaction. If energy is entering, we say that is a endothermic reaction, and it's a positive sign. Now, the best, one of my favorite diagrams ever. So I always think of the system, whenever we're dealing with this, is the greedy child. Anything you do for it is positive, anything that it has to do is negative. So if we take a look at actual equations here, you can take a look at this equation right here where heat is being inputted in. That means that our change in enthalpy will be a positive value. And again, positive just indicates that energy is being inputted. Conversely, in this reaction right here, we have a change in enthalpy. And normally you'll see with the changes in H, you'll see this change in enthalpy. And if it's for the entire reaction, you'll see RXN, short for reaction. But I want to circle this here. You see how it's a negative value? So that simply means that exothermic reactions give off energy. And this makes us really smiley and all kinds of great. So this is a very small video just to remind you that exothermic reactions, you give off energy, endothermic reactions take it in. And in particular, I want you to feel familiar with these two graphs where you have the reactants at higher energy and the products at lower energy, which is great because you're getting rid of energy, and who doesn't mind that? And here, we're ending up with products that have more energy, and that's not great at all. I should have had an E on this side here and then time going right here. Hopefully this has helped. I'll see you in the next video. Thanks.